Today we are going to discuss estimation of carbon, hydrogen, nitrogen, and sulfur, phosphorus, halogens like this. So this is a quantitative analysis of organic compounds. So here, what we are going to discuss in this quantitative analysis. So what are the estimations? Actually, there are three types of methods are there. The first method is Leibig's. Leibig's estimation of Leibig's method of estimation of carbon and hydrogen. So this method is used for the estimation of carbon and hydrogen, especially for that, which is present in organic compound. Okay. So next one is second one, Carius method. So Carius method for estimation of halogens. Here X means halogens, that is chlorine, bromine, and iodine. So here we are, we can't estimate the fluorine because fluorine cannot form a precipitate. So that is the reason we can't estimate the fluorine here. And one more thing is we can estimate sulfur and phosphorus also. So this is the second method for the estimation. And the third method is a very important, is nothing but estimation of nitrogen. So estimation of nitrogen, for the estimation of nitrogen, there are two methods now. One is Dumas method and another one is Geldahl's method. So here Dumas method and Geldahl's method both are very important, and here Geldahl's method is the most important, most commonly used method for the estimation of nitrogen more accurately. And Dumas method also we are using that. Okay, so we can see one by one. Okay, next step. So the first one is I am going to take Leibig's estimation. Leibig's method of estimation of carbon and hydrogen. Here, for this estimation, every time we have to take the known amount of the organic compound. The known amount of organic compound we should take. So what is that known amount in the sense? So for example, zero point 0.5 or 5 grams, 1 gram, 2 grams of organic compound. So in that organic compound, how much percentage of carbon and how much percentage of hydrogens are present? So for this, a simple diagram of this. So, actually how we conduct the experiment by using the experimentations processes only we can get the estimate, we can estimate, I'm sorry, we can estimate the carbon and hydrogens. So what is that? So let's close it completely. So here we have to pass the atmospheric oxygen, and these you see here two U-shaped tubes should be used. So this is actually experimentational setup. Right. This is the two U-shaped tubes which we use, and in one of the tube we have to use the calcium chloride, anhydrous calcium chloride. We have to take the anhydrous calcium chloride. In another test tubes, we have to use the KOH, sorry, KOH actually. So KOH, why we have to use and all we can discuss. And in this one very important thing it is, remember. So we have to take the platinum boat. We have to take the platinum boat here. So in the platinum boat, we have to take the organic compound. Organic compound with copper oxide. Okay. Organic compound with copper oxide we should take. Let's take this also the copper oxide also we have. Right. Copper oxide actually it is in black in color. Okay. For your reference, I am taking uh, in the different color. Okay. We have to heat this. So we have to heat it using the Bunsen burner. So this is the complete experimental setup. So what is this? This contains organic compound and copper oxide. So here we are giving heat and we can get the some colorless gases we can get. So what are the gases we can get? We can observe. So first of all, actually an organic compound contains carbon and hydrogens, right? So let's take carbon. If carbon can react with the Cu, you can get that car also CO2 and Cu. So two CO2 and Cu you will get that. Sorry, two CO2 you can get. So this CO2 gas can be produced. CO2 gas can be produced. And hydrogen is also present in that organic compound, right? So that's why hydrogen also can react with the copper oxide. It can produce that H2O and Cu. Here, H2O and Cu both are in gaseous mode. And now these CO2 is absorbed by absorbed by anhydrous calcium chloride. So this is anhydrous calcium chloride and this is nothing but KOH solution. And H2O is absorbed by KOH. So calcium chloride and calcium chloride and CO2 can be absorbed by the calcium chloride and the H2O can be absorbed by the KOH. So by knowing the weights of these, we can estimate the we can estimate the weight of the amount of the carbon as well as percentage of the carbon. So we have to take them outside and before that we have to calculate the weight. Okay, known weight of calcium chloride, known weight of KOH. Later that we have to weigh. So by using that, we can get the amount of CO2 formed, amount of H2O formed, we can get that. Okay, so simply. Now, general thing is, we know that 44 grams of CO2 can be produced, can have 12 grams of carbon, right? So like that, this much, we don't know how much amount of CO2 is produced, but it can comes from the experimentation. So let's consider X grams of CO2. So X grams means here you can remember comes from experiment. Experiment. Okay. Grams of CO2 contains how many grams of carbon? It's a simple thing. So you can take it as amount of the carbon. Amount of carbon is equal to cross multiplication. You can do this. That means X into 12. So 12 into here X means amount of CO2 formed. Okay. So you can take like this amount of CO2 formed. Otherwise, you can do one thing. You can take here X. So here X is equal to, you can take like this amount of CO2 formed. Right. So 12 into X divided by 44. So this is the amount of carbon which is present in the organic compound. So basing on that, problems will come. And now we should find out the percentage of carbon. So now percentage of carbon, how can we find out the percentage of the carbon? So that is nothing but actually this is the amount of carbon which is which contains the organic compound, right? Some amount of organic compounds. We know that. Let's take here, yeah, here you can take. So let the weight of or amount of organic compound is equal to W grams. Let's consider like that because some amount is the total amount of the organic compound is W grams. In that carbon contains this much amount of the uh, weight. So that's why you should percentage of carbon is nothing but weight of the carbon divided by you can get amount of carbon divided by total amount of here instead of amount you can take weight. Okay, weight of carbon, total weight of organic compound into 100. Okay, so we can apply this one into this formula. So percentage of carbon is equal to 12 into x. What is x? We already told you already. So divided by total weight is W grams into 100. So this is the percentage of, I'm sorry, 44 is also there. 44 into W grams. Okay. So this is the formula for the means percentage of carbon, estimation of the carbon like that. So estimation of now hydrogen content. So same compound only. So here you can see the reaction. Hydrogen dioxide it can form the H2O. H2O can be calculated by the experimentation. Okay. So here let's take let Y be the weight of water formed. Right. So you know that according to this, normally 18 grams of water contains 2 grams of hydrogen, right? But we do know some amount of Y grams of the water formed. So that's why Y grams of H2O contains how many grams of hydrogen. So we can write that weight of hydrogen is equal to cross multiplication. Okay, 2 into Y. Y means weight of H2O formed divided by 18. So this is the weight of hydrogen formed. So like that, we have to find out the percentage of hydrogen. Percentage of hydrogen as usual. Previously we have done for the hydrogen for carbon. So same like this. Percent of carbon means weight of carbon by total weight of organic compound into 100. So like that, weight of hydrogen by total weight of the organic compound into 100. So like that, you can see 2 into Y divided by 18, weight of the compound. Actually, whole divided by W you should take into 100. So here, this ratio can be reciprocal, we know that. So that's why we can get that percentage of hydrogen is equal to 2 into Y divided by 18 into W into 100. So this is the estimation of Leibig's constant. So let's take some examples. Example. Uh, if 0.5 grams of organic compound estimated by Leibig's method method 0.44 grams of CO2 formed. So the amount, the weight or the percentage of carbon present in the organic compound. It's a very simple question. We know that. So percentage of carbon is equal to percentage of the carbon is equal to 2 into x means weight of CO2. It's the 2 or 12. We should take the 12. 2 for hydrogen. Weight of CO2 divided by 44 into weight of organic compound into 100. So very simple one, right? You can apply 12 into weight of CO2 given 0.44 divided by 44 into weight of organic compound is 0.5. 0.5 into 100. I think 100, 0.44 and 44 we can cancel because if you have multiply both 44 will come. 44, 44 can be cancelled. So 12 divided by 0.5. We can take into 10 by 10 we can do 120 by 5. 5 to 10, 5 4 20. That is 24% of carbon present in that organic. Okay, simple. It's a very simple manner we can find out this.